Hello everyone, Bhargav here. Today we are going to study about permittivity. To take it simply, we can define permittivity as the ability of a substance or a medium to reduce electric force between charges, and it is written as epsilon. Okay, so let us have some insight about the electric force between charges. Okay, let's go. As we know, the charges have some forces between them. For example, like charges repel each other and the unlike charges attract each other. Okay, so what is the force acting between them? It is given by Coulomb's law. Okay, so let's have some example. There are two charges Q1 and Q2 and they are separated by some distance r. So logically speaking, whenever the magnitude of the charges is greater, the force will be greater, obviously, and also when the distance is greater, the force will be less. So it is given by the Coulomb's law with this equation. So the force between them is directly proportional to the magnitude of the charges and also inversely proportional to the distance between them squared. And also there is one other factor which also depends the forces between them. It is the medium between the charges. So where the charges are kept is known as the medium, and it depends on the medium. So this K is the term which is dependent on the medium, and this K can be written as 1 by 4 pi epsilon, and this naught is for the medium which is vacuum, or we can say it free space. There is nothing between them. So this epsilon naught represents the permittivity of free space. Okay, let's have some insights in this permittivity. What is permittivity? And let's have some deep why this permittivity comes into being. Okay, before learning about permittivity, let's have some insight into electric field. So what is electric field? Is nothing but the force per unit charge. So it is the force Coulomb force, but it is for a unit charge. So it can be written as E is equals to 1 by 4 pi epsilon, which is the K, and also Q divided by R square. Also these electric fields can be represented as lines. If you put a charge here, the force that will be acting on it will be in this line. So we can represent electric field into lines. These blue lines can be represented as the electric field lines, and we will study about them later. Okay, let's take an example. Let's have some two plates and there is a medium. The yellow color is a medium and this blue color are the plates. Okay, so first of all, in the medium there will be some molecules, and in molecules there are positive charges and negative charges. Okay, so let's represent it like this, positive and negative. In absence of an electric field, they will be oriented randomly and they will cancel each other. So there will be no net electric field between them. But let's apply some charges in these plates. Let's say we apply positive charge in this blue plate and negative charge in this blue plate. And because of these charges, there will be electric field E naught from the positive to negative. And because of this electric field, the orientation of the molecule will change, because the negative charge will get attracted to the positive charge and also the positive charge will get attracted to the negative charge, and because of this plate, so they will orient like this, and they will also create an electric field of themselves, let's say EM. So the net electric field of this system will get decreased. Let's say the E net will be E naught minus EM. Okay, so this can also be written as the E net equals to E naught divided by epsilon R. This epsilon R is known as relative permittivity. We can also cite it like this: the E naught has been decreased by some factor, and this factor is known as this relative permittivity. We'll learn about the permittivity, what is relative permittivity, in the next slide. Okay, so we have seen that electric field decreases due to presence of the medium by a factor epsilon R. This is relative permittivity, and it is the permittivity of the medium divided by the permittivity of the free space or vacuum. There should be a question, as I have explained permittivity as the ability to reduce force due to the presence of molecules, but there is nothing in vacuum. So what reduces the electric field in the vacuum, and why does this value comes out? This value, first of all, the maximum force is in the vacuum, and any other medium it is less. If there is nothing to reduce the forces between them will be infinite. But that's not the case. It has a finite value, and after carefully calculating the forces between the charges in vacuum, this permittivity value comes out, which is epsilon naught, or permittivity of free space. It's an experimental value. In vacuum, there can be something like space-time, which is being studied right now by our scientists. So we have till now not been able to understand this phenomenon as to why it happens. But having said that, we are now concerned about the value and how it affects the charges. Okay, so let's sum up what we have learned. So permittivity is the property of a medium as to how it reduces the electric force between them, okay, between the charges. So the forces acting between charge is maximum in the vacuum and it is less in other medium. So the epsilon naught have the least value in the vacuum, which is 8.85 into 10 to the power minus 12, and every other medium it is greater. Okay, so we can also technically, if you define permittivity, it is the ability of a substance or a medium to store electrical energy in the form of electric field. So when I have explained you about this phenomenon of the material, you have seen that electric field has been produced in the medium. So since electric field is produced in the medium, so this electric field can be stored as an electrical energy. So this is the true definition of permittivity. Okay, these are different values of relative permittivity for different mediums. So for vacuum it is n obviously, and air is almost 1. So vacuum and air are considered to be equal, and for other materials it is given. Okay, so thank you. This is all for this permittivity video. We'll catch up next time. Okay, thank you.